There's a tool that's revolutionized our society. It's an artist, a historian, and it's in every pocket. It's called a digital camera, and you've probably heard of it. How does it work though? And how did Albert Einstein play a pivotal role in discovering the science behind our Snapchats? It's common knowledge that Albert Einstein received a Nobel Prize for revolutionizing our modern understanding of physics with this equation E=mc². Except for the fact that he didn't. He actually won the 1921 Nobel Prize in Physics for his paper on the photoelectric effect. It turns out that when light hits a material, it can give the electrons a red card, resulting in immediate ejection from their otherwise stable orbits. Experiments discovered that only certain intensities of light above a certain threshold energy were able to do this though. If a light were a continuous wave, as was accepted by the scientific community at the time, a less intense light would eventually build up enough energy to eject an electron after a time delay. But this doesn't happen, so Einstein came to the conclusion that light couldn't travel as a single continuous wave, and instead had to travel in wave packets, which are now known as photons. This was the beginning of our modern understanding of wave-particle duality. Enter the charged coupled device, which converts incoming photons to electrons using the photoelectric effect. The resulting rainstorm of electrons will then be collected as electric charge in capacitors known as pixels, much like how you can collect rainwater in a cup, except the rain is lightning bolts. The great innovation of the CCD was using a bucket brigade to simultaneously shift the charges row by row down to a single readout channel where they would be turned into electronic data, one line at a time. When the electrons hit the readout, they're emptied into an analog to digital converter, which is similar to a measuring cup with 256 lines. Each line will then return a 1 if there's enough voltage to pass through the resistor, and a 0 if there isn't. This is then converted to a brightness value for that pixel ranging from 0 to 255. The CCD has a limitation though, and that's the speed at which the bucket brigade can move the charge down to the readout. For these and other reasons, most modern cameras are complementary metal oxide semiconductors, or CMOS. These capture the electrons in the same way, but have amplifiers and wires connecting to every pixel, allowing for them to all be emptied at the same time. So now we have the brightness of individual pixels and can extract a black and white image. How do we get color though? Color is achieved by attaching a filter known as a Bayer filter that only allows certain colors of light to hit certain pixels. There are almost twice as many green pixels because the human eye is almost twice as sensitive to green light as it is to red or blue light. Now that we know the brightness of a pixel and have a color assigned to that level of brightness, the camera can apply an algorithm that will average the reds, blues, and greens from the surrounding pixels into a single RGB hexadecimal value. This is essentially taking primary colors and mixing them together in order to get more complex ones like yellow, magenta, or cyan. Thanks to the photoelectric effect, we now have digital cameras that can capture every moment of our lives, and they cost less than a Saturn V.